let us look at hydrates of non-metals. There are very interesting questions on this particular topic. And look at these hydrates of fourth group: CH4, SiH4, GeH4, SnH4 and PbH4. Methane, silane, germane, stannane, plumbane. What is the sound common? Ne. Ne. So, better hydrates be called Ne. Methane, silane, germane, stannane, plumbane. That's why we call BH3 as borane and B2H6 as diborane. You must have heard about that, diborane. So, the sound Ne suggests that it is a hydride, especially non-metal hydride, diborane. It is also a hydrate. Now, these are the hydrates of group 4A: carbon, silicon, germanium, stannum, plumbum. And hydrates of fifth group: NH3, PH3, phosphine, ASH3, orsine or orsane, phosphine, orsine, stibine, bismuthine. And the hydrates of sixth group: H2O, it is water. No point in calling it oxane. Of course, it may be called oxane, but there is no point in calling it oxane because it is popularly known as water. Everybody knows water. H2O, H2S, H2Se, H2Te, H2PO. So, carbon, silicon, germanium, stannum, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium. We have covered three groups. And the halogens, when they combine with hydrogen, they better not be called hydrides. They are hydrogen halides. Hydrogen halides. Hydrogen halides. HF, HCl, HBr, HI. Hydrogen iodide. So, they are not, strictly speaking, they are not hydrides. In a hydride, HF, HCl, HBr, HI. Hydrogen fluoride, hydrogen chloride, hydrogen. This is hydrogen sulfide, hydrogen selenide, hydrogen telluride, hydrogen polonide. So, what are the questions? What are the questions that are possible? First, let us discuss a few concepts and then we'll straight away, we can go to questions later on, not now. Now, first question on hydrides is their stability. Stability of hydrides of non-metals. Stability of hydrides of non-metals. Small atoms form stronger bonds. Small atoms form stronger bonds. Everything about halogens is an exception. Everything about halogens. I am not talking about compounds of halogens, mind you. I am not talking about compounds of halogens. I am talking about halogens in their elementary state. Everything about halogens is an exception. Slightly unexpected things happen in halogens. So, small atoms form stronger bonds. So, when I say HF is stable, HF is thermally stable. What do I mean by that? HF is thermally stable. When I say that, HF on heating doesn't give hydrogen and fluorine atoms easily. That is what is meant by thermal stability. You heat HF to a temperature of 400, 500, 600. Even at a very high temperature, it doesn't break into hydrogen and fluorine atoms easily. Why? Why does it break? Because the HF bond is very strong. It is a highly polar bond. It is very strong. So, small atoms form stronger bonds and a molecule formed by smaller atoms on heating doesn't decompose easily. Therefore, it is said to be thermally stable. So, the thermal stability of hydrates of fourth group: methane, silane, germane. Now predict which is most stable? Methane. Why? Carbon is a small atom, carbon hydrogen bond, silicon hydrogen bond is a little longer. So smaller the size, greater will be the overlap and stronger will be the bond and more stable is the molecule. Smaller the size, greater the overlap and stronger will be the bond. So carbon hydrogen, silicon hydrogen. So methane, stability, methane is more stable, not less stable. Stability of methane is greater than silane, greater than germane, like that. Greater. Methane, silane, germane, stannane, plumbane.